Hi everyone, we're back for revision for first year final exam question. So this time we're going to have a look at one example from Fourier Series. And this is a question from past year final exam in 2019-2020. So just last year question. Okay, so please be reminded that Fourier Series will be one of the compulsory questions as well. And you have to answer this question from Fourier series. Let's have a look at this question. And okay, for this question, two periodic signals at CT and Fcmt are given in this figure. Okay, so there are two signals here, and you need to have a list of formula in front of you. Okay, so for this question, we need to look at the table of Fourier series coefficient and determine the complex exponential Fourier series equations for both XCT and Xmt up to the third harmonic. So it means that n is equal to 3. Okay, and if you have a look at the marks here, the marks given is 4. So it means that 2 marks for XCT equation and 2 marks for Xmt equation. Although the solution is quite lengthy, but the mark is only 2 marks because it is considered straightforward question. Okay, and for question number 2, here you have to determine the trigonometric cosine form of Fourier series equation for both XCT and Xmt. So once you obtain complex exponential Fourier series equation, it should be no problem for you to determine the trigonometric cosine form. Okay, so let's start with square wave. So you refer to the list of formula. So you find the formula for square wave. Okay, and then first of all, you have to determine also the amplitude for XCT and also the duration. Okay, the T naught. Okay, the duration. So if we see here, the amplitude for XCT is 1 and the duration is 0.1. Okay, so x naught is equal to 1, okay, and the duration is 0.1, and you have to notice as well the unit. So the unit here is millisecond. Okay, so it is 0.1 millisecond. Hence, we can get omega naught as 2 pi over T naught, which is 2 pi over 0.1 millisecond, which is equivalent to 2 pi multiplied by 10 power of 4 radian per second. Okay, and then we look at the table of formula. So from the table of formula, it's given that C naught is equal to 0. Okay, it means that when n is equal to 0, the complex coefficient is 0. And Cn is given as negative j to x naught over pi n. And there's a remark there which Cn is equal to 0 for n even. So it means that for n equal to 2, 4, 6 and so on will not be counted because it is 0. Okay, and the overall equation for complex exponential form for Fourier series is equivalent to summation of, because the question asks you to find the equation or find the complex exponential Fourier series coefficient up until third harmonic. So it is equivalent to from n negative 3 to n equal to 3, negative j to x naught here is 1. Okay, so j2 divided by pi n exponent j n omega naught t. Okay, so we put in the equation. It is vital for you to find this omega naught so that we can put in the equation later on. Right. Okay, now we find for each harmonic. So we just need to find for 1 and also 3, since when n equal to 2, Cn is equal to 0. So C1 here is equal to negative j2 divided by pi, because n is equal to 1, and C negative 1 will become j2 divided by pi. Okay, the negative here is gone because negative divided by negative 1, which is n, is positive. right? So C3 is equal to negative J2 divided by 3 pi, and C negative 3 is equal to J2 divided by 3 pi. Okay, and we put the overall equation here, which is at CT is equal to J2 over 3 pi. So we put for the smallest harmonic first, which is negative 3. Okay, so J2 over 3 pi, and then put exponent J. So when n is equal to negative 3, we multiply by omega naught, which is 2. So it should be negative 6 pi. So negative 6 pi multiplied by 10 power of 4 t. Okay, and then we put for n equal to negative 1. So this one is J2 over pi. Exponent negative J2 pi multiplied by 10 power of 4t, and then for C1, okay, plus because C1 here is negative, so we have to put negative here. Okay, put negative minus J2 over pi exponent J2 pi multiplied by 10 power of 4t, and minus J2 over 3 pi exponent J6 pi multiplied by 10 power of 4t. Okay, so this is the answer for XCT, and let us do now another equation for SMT. Then the next one is for XMT. So XMT is actually a triangular wave. Okay, so you refer to your table of formulas for Fourier series. What is the formula for triangular wave? Right. So now we have a look at the amplitude here, still 1. And for the duration here, or T0 is 1 millisecond. Okay, so we can put here, x0 is equal to 1. And omega naught is equal to 2 pi, because T0 here is equal to 1 millisecond. So divide by 1 millisecond. This is equivalent to 2 pi multiplied by 10 power of 3. Right. And then from the formula, you find out that Cn is equal to negative 2 x0 over pi n squared. Okay. Since x0 is equal to 1, so Cn is equal to negative 2 divided by pi n squared. Right. And then for C0 is equal to x0 over 2, which is 1 over 2. And there is also remarks here where Cn is equal to 0 for n even. So similar to at C here, we just have to find until third harmonic. So it means that we have to find for first and third harmonic only. Okay, because second harmonic is 0. And then C1 is equal to negative 2. Okay, and then put n is equal to 1 in this equation. So it becomes negative 2 divided by pi squared. C negative 1 is equal to negative 2 divided by pi squared, which is the same because when you square the negative, it becomes the same number. Okay, C3 is equal to negative 2 divided by 9 pi squared, and C negative 3 is equal to negative 2 divided by 9 pi squared. Okay, so XMT is equal to, don't forget this, okay, don't forget the DC component, which is 1 over 2. So equal to 1 over 2 minus, okay, if you want to take from the smallest one, so this is the smallest component, negative 2 divided by 9 pi squared. So this one is exponent, okay, we have to multiply by exponent Jn omega naught t. So n in this example here, okay, for this component is negative 3. So negative 3 multiplied by 2 pi, it is negative 6 pi. Pi multiplied by 10 power of 3t, okay, 10 power of 3t, and then minus the second smallest one is negative 1, 2 over pi squared, exponent negative 2 pi multiplied by 10 power of 3, t, and then minus 2 over pi squared. Exponent this time is positive. Sorry, I missed the j here. Should be j here. Okay, exponent j2 pi multiplied by 10 power of 3t, and finally minus another component, which is 2 over 9 pi squared, exponent j, and this time is positive, 6 pi multiplied by 10 power of 3t. Okay, so basically this is the equation for complex Fourier series. Okay, so the keyword here is complex. So when it says complex, then you need to put the equation in terms of exponential function. You need to find Xc and Xct and Xmt here in the form of trigonometry series. Okay, so for trigonometry series, it means that it is either cosine or sine function. Okay, so for Xct, we have obtained in terms of exponential. So make sure that what you have obtained is in terms of exponential function, complex exponential function, is correct. Otherwise, we'll get this part wrong. So Xct is equivalent to, I wrote this back, j2 over 3 pi. Okay, so let me write this one back first. We write again the answer from previous question. Okay, so we notice here that there is a negative here, so we have to change it to positive because we want to put in terms of cosine function. Okay, how I'm going to change this, also how I'm going to remove this j. Okay, so let us do for this one first. Okay, for n equal to 1. So this j I'm going to put as exponent j pi over 2. Okay, so we can put it like this j, right? So, and please do not remove this because we have still to multiply these components. So exponent negative j 2 pi multiplied by 10 power of 40. Okay, and then we take for another same harmonic, this one. Okay, so for this one, this negative j, I have to change it to positive, so it will become 2 over pi here, over pi. Okay, exponent negative j pi over 2, so we make it negative here, and then this one is still positive, multiplied by exponent j2 pi multiplied by 10 power of 40, and the same goes to this one. Okay, 2 over 3 pi. Okay, I put it as exponent j pi over 2. Okay, because we can change j here to exponent j pi over 2. Basically, it's just changing to exponential number. And this one is exponent negative j6 pi multiplied by 10 power of 40. And finally, this negative, okay, this component becomes 2 over 3 pi exponent negative j pi over 2 multiplied by exponent j6 pi multiplied by 10 power of 40. Okay, so from here we can rearrange so that it become we can use the Euler function. Okay, so you have to remember Euler function. To cosine function, you cannot just simply take from this. Okay, you have to use this Euler function. Okay, you have to rearrange so that this function, actually this function will be double when we put cosine. Okay, the number here will be double. Okay, you cannot just simply convert from here to the cosine function. You have to use this Euler's function. Remember that because I've seen many of you did that during the quiz and also during the test. Okay, so from here we rearrange back. Let's say we rearrange for the first harmonic here. It should be 2 over pi, we put outside the bracket, and then exponent j. Okay, j, we took it, we put it outside the bracket, 2 pi, okay, for this one. multiply by 10 power of 4t. And then when we take the j here, what's left here is negative pi over 2. So minus pi over 2. Okay, plus this part, exponent, we take out negative j here. So 2 pi multiplied by 10 power of 4t. And then because we took negative j out, so what left here is negative pi over 2. Okay, negative pi over 2. Why? Because negative multiplied by negative here will become positive. So what you have to remember, one more thing is, whatever with t here, this is omega. Okay, whatever j with t here, this is omega, and this part with no t is the phase. Okay, is the phase shifting. Because I've seen that some of the students, they got confused because they put this one as the phase and this one as omega. So this is not correct. The one you put, you should regard it as omega, is the one with t at the back. Okay, so this have t at the back here. So this should be omega. Okay, because remember it's actually exponent j omega t, right? So minus pi over 2. So the one with no t here is actually the phase. Okay, so we have first component. Okay, we have to multiply 2 over 2. It's actually it's like that we multiply 1, but why we want to multiply 2 over 2? Because we want to make this equation looks like this. Okay, so we cannot just simply divide by 2, because this equation, you cannot simply just add something into this equation without changing on the left hand side. Okay, if you want to change on the right hand side, you have to change at the left hand side also. But if you multiply 2 over 2, it's actually you multiply by 1, which doesn't give you any changes for the equation. Okay, so you put like this, and then we plus another part, which is n equal to 3 here. So you take out 2 over 3 pi from the bracket, and then take the first positive omega first. So exponent j, 6 pi multiply by 10 power of 4 t. And then here, because we already take out j here, so this one is negative pi over 2. Okay, and then plus exponent negative j for this one, 6 pi times 10 power of 4 t and negative pi over 2. Okay, similarly, because when we put negative j outside, so this one will become negative pi over 2, because negative multiplied by negative will become positive here. Okay, and then here again we multiply by 2 over 2. Okay, so that it follows this Euler function. Okay, positive plus negative exponent divided by 2, we can change it to cosine function. However, these two, please remember, 2 at the numerator here, at the top here, have to be multiplied with this. Okay, so here it will becomes 4 over, okay, 2 multiplied by 2 is 4, and at the denominator is still pi, and this one become cosine 2 pi multiplied by 10 power of 4t minus pi over 2. And then this one, for this part, is actually 2 multiplied by 2 is 4 over 3 pi cosine 6 pi multiplied by 10 power of 4t minus pi over 2. Okay, so this is the answer for Fcmt. Okay, now we want to find for Fcmt. So for Fcmt, I have already copied back from the previous question. This is the answer from previous question. So what we have to do now, we have to, if you want to make it in cosine function, which is easier, okay, because for Fcmt we have already make it in cosine function. So what we have to do now is we change these negative numbers to positive by multiplying this with exponent j pi. Okay, we change it to exponential number here. So it become 1 over 2 plus 2 pi squared exponent j pi exponent j 2 pi multiplied by 10 power of 3t And for all of this equation, we multiply by exponent j pi. So these numbers, negative numbers here to positive by multiplying with exponent j pi. Okay, previously for this equation, we changed from j here to exponent j pi over 2. Okay, this is how you want to change from a negative number to positive number using the exponential function. Okay, this also have been changed to exponent j pi, and this one is multiplied by exponent j pi, and this one also multiplied by exponent j pi. So again, don't be confused with the omega. Omega is here, and this j pi should be the phase. Okay, and we have to rearrange this equation so that it follows the Euler function. Okay, just like what we have done here with at CT. Okay, so that we can put it as in terms of cosine function. So what it will be here is 1 over 2, and then we take out 2 over pi squared from the bracket. Okay, put exponent j, and remember to put the omega first, which is 2 pi multiplied by 10 power of 3t, which is this one, and then only you add with pi. Okay, there's no more j because we already took out j here, plus exponent negative j. When we took out the negative j here, what's left is 2 pi multiplied by 10 power of 3t. However, this is a bit tricky here. Okay, let's say if we want to put plus pi here, okay, but this mathematically, when we refer to this, is not correct, because when we put plus pi here, negative multiplied by positive, it should be negative exponent j pi here, okay, which is not the same. So what we can do is actually, if we refer back to the trigonometry circle here, here is pi, which is 180 degrees, but here is negative pi. So it gives you the same point at the coordinate. Okay, so what we can do here is at the negative j for the omega, for the negative omega, we can put as negative j pi. Okay, so we put negative j pi for each negative omega. Right. So here it will follows this equation. For example, negative j multiplied by pi will become negative exponent negative j pi. It is correct. Mathematically, it is correct. Okay, and then we close the bracket. We multiply by 2 over 2 so that we can use the Euler's function after this. Right, and then we take out 2 over 9 pi squared. Okay, in the bracket, what's left is exponent j, put the omega first, which is 6 pi multiplied by 10 power of 3t plus pi plus exponent negative j, 6 pi multiplied by 10 power of 3t minus pi. Okay, so sorry, plus also pi. Okay, because negative multiplied by positive will be exponent negative j pi here. Okay, and this one also multiplied by 2 over 2. Okay, so what we obtain here is 1 over 2 plus, okay, don't forget to multiply this. So 2 multiplied by 2 is 4 over pi squared, and for this part, it will become cosine function. So this one is cosine 2 pi times 10 power of 3 t plus pi. Okay, so the phase here is pi, and the omega here is 2 pi times 10 power of 3. And then this one, 2 multiplied by 2 is 4 over 9 pi squared cosine 6 pi multiplied by 10 power of 3t plus pi. So now you have answered both at CT and at SMT. And if you notice, it is quite a lengthy operation here. And this one also is quite long. However, you will only get 3 marks for question 2 and also 4 marks for question 1. So practice makes perfect. So if you practice regularly how to obtain this coefficient, and also how to obtain from exponential coefficient to cosine, then I believe you will you can do this within the time allocated for you. And if you see the marks there is not that much, because the question is actually straightforward. Okay. in my opinion, is quite tough. So we have not finished this question yet. We just get to question B. A modulator block diagram for amplitude modulation system is shown in this figure. Both Fcmt, which we obtained from the previous question, and Fct are the inputs to this AM system. Okay, so we have to consider up to first harmonic terms for both. So remember, once you got it wrong for question A, then you got it wrong for question B as well. So this is very dangerous, right? And then first, determine the trigonometric cosine form of Fourier series for x naught t. Okay, it means that we have to multiply Fmt and Fct together. Once we obtain x naught t, we have to sketch the single-sided spectrum for Fmt, Fct, and x naught t. So when the question asks you to sketch the single-sided spectrum, so it means that we have to plot in terms of trigonometric cosine form. Okay, so let us do this. Determine the x naught t first. Question B1, x naught t is Fmt multiplied by Fct. So we only have to consider first harmonic. Okay, it means that n equal to 1. Okay, however, do not forget the DC components as well. Okay, because DC component is when n equal to 0. So for Fmt, for n equal to 1, we have 4 over pi cosine 2 pi multiplied by 10 power of 40 minus pi over 2. So this is from previous answer that we obtained. Multiply by, for Fct, we have DC component 1 over 2 plus 4 over pi squared cosine 2 pi multiplied by 10 power of 3t plus pi. Okay, so we multiply this equation, become 4 pi multiplied by 1 over 2, it will become 2 over pi cos 2 pi multiplied by 10 power of 40 minus pi, this one is big t here, pi over 2, and then another one is 4 pi multiplied by this 4 pi squared. It become 16 over pi power of 3 cosine. So we have two cosine function here. First, cosine 2 pi multiplied by 10 power of 40 minus pi over 2, and then we have this component, cosine 2 pi multiplied by 10 power of 3t plus pi. Okay, and then what we can do here, we can use the trigonometry identities. These trigonometry identities, which you can obtain from the list of formula. Cosine A multiplied by cosine B equal to 1 over 2 cosine A plus B plus cosine A minus B. So we can do that to simplify this equation. Okay, so this one will become 2 over pi multiplied by 10 power of 40 minus pi over 2 plus, so 1 over 2 multiplied by 16 divided by pi squared, it will become A over, sorry, not squared, pi power of 3, and then here it will become cos. Okay, you have to add this one together, and then you have to minus this one together. Okay, so let me speed up this solution. Ready? So basically this is from here, okay, and plus B is from here, okay, and then A is from here, and then you have to minus this component 2 pi multiplied by 10 power of 3t, and then because of minus, this one also become minus. Okay, and you solve for this, it will become, okay, this is how the equation look like after I have solved this. Basically, you just add together the omega, the one with the t here, and then add together the phase. Okay, so for this one, the phase negative pi over 2 plus pi become pi over 2, and this one negative pi over 2 minus pi, it will become negative 3 pi over. Okay, so basically negative 3 pi over 2, if we see here, is actually the same as pi over 2. Okay, so we can also change this to plus pi over 2. Okay, so to make the phase same as this, you can change it to plus pi over 2. So if you put negative 3 pi over 2, it's still correct. Okay, so because negative 3 pi over 2 is actually negative 270 degrees, which is this location, this coordinate. And pi over 2 is this one as well. So it's the same. Okay, and then from here we can plot the single-sided spectrum for x0t, Smt, and xct. Okay, so for Smt we have two components. Sorry, for xct first. Okay, so for xct we have two components in the first harmonic and also third harmonic. So we have the first harmonic, we have 2 pi multiplied by 10 power of 4. Okay, this is t, and the coordinate here is, sorry, the coordinate, the magnitude here is 4 over pi. And for another one, which is 6 pi multiplied by 10 power of 4t, so you can refer back to the previous answer, right? And then this one is 4 over 3 pi. And for xmt, we have three components together with the BC value. Okay, so for SMT, this one is also 2 pi multiplied by 10 power of 3. Sorry, this is 3, is 6 pi multiplied by 10 power of 3. Okay, so remember to label all the x's. And then for the first part, we have 1 over 2, which is the DC part. And then we have something like this, 4 divided by pi squared. And then we have shorter components, which is 4 over 9 pi squared. And for x and t, we have 1, 2, 3. Okay, 1, 2, 3 component. Sorry, for x not t. X not t. Okay, label, because we need to know which plot is for which signal. Okay, we have 1.8 times 10 power of 4. And then we have 1.6, sorry, 6 pi. And this is 1.8 pi. Let me correct it for you. Three components at 1.8 times 10 power of 4 t. This one, okay, the smallest one. Then we have 2 pi. So, sorry, we have 2 pi. This is pi, okay, times 10 power of 4. And then another one is 2.2, which is this, times 10 power of 4. Okay, and the magnitude here, the first one is 8 over 3 pi power of 3. And then the second one is 2 over pi. And finally 8 over pi power of 3. Okay, so now you answered both questions for question B. We have not finished a question for Fourier series. Okay, still in on question B, we have question B3 actually. You need to calculate average signal power of S naught T. So you already obtained S naught T. And then number 4, if a low pass filter with amplitude gain of 20 dB is used before the antenna, calculate the average signal power of Xamt. Okay, so if we go back to the diagram here, this is X naught T, and then you need to find Xamt, provided that X naught T go through this low pass filter with gain 20 dB. Okay, so for question B3 here, we just use the Parseval theorem. So for Parseval theorem, we just use the formula for single-sided spectrum. So C naught squared plus 1 over 2, and from n equal to 1, summation from n equal to 1 to infinity Cn squared. Okay, so from here, we put the value for C naught squared, but for X naught T, there is no value for C naught squared. Okay, if we look at X naught T here, okay, this one is S naught T, so we just take the value of each of the spectrum here, okay, and put in the equation. So what we have now here is 1 over 2, and then you put the each of the component for the spectrum for X naught T, and you square and divide by 2, and then this is the answer that I obtained. So please let me know if I have wrongly calculated this. Okay, and for question number 4, this X X naught t goes through the low pass filter with 20 dB gain. So this is quite tricky, okay, because 20 dB is actually the gain. So basically for the filter, we know that this is a low pass filter, for example. Okay, so it has gain here. So we need to find the x here so that we know how much that we need to multiply with x naught t. So x here, okay, is actually 10. So it means that 10 time increase in the voltage of in the output voltage, which is x naught t. Okay, so here we will get Fcmt equivalent to x naught t multiplied by 10. So this is actually you can actually multiply x naught t by 10. So I'm not going to write it again here. So let me just go to the straight to the question, which is to calculate the average signal power of Fcmt. Okay, so basically for this we need to use the Parseval theorem as well. So this is P average for Fcmt. Okay, still we need to use 1 over 2. So x naught t multiplied by 10. So we know that x naught t is this component. Okay, so we multiply by 10. This is 20 over pi square. Okay, so we put in the formula here. Okay, this is 8 multiplied by 10, so 80. Okay, and then this is the value that I obtained, which is 26.93 watts. So let me know if this answer is wrong. So finally, we have answered all questions for question B. We move to question C. This is quite the solution is not that long, but it's quite a tricky question. Okay, so a square wave signal of 20 millisecond period and peak-to-peak voltage of 2 volt, which is regarded as xt, and this xt mimics the signal of xct, means that it looks like the signal of xct from QA above. So xct from QA is actually a square wave signal. So this is the input voltage to a circuit as shown in figure Q3C below. Okay, so by considering only the fundamental frequency, so this is the thing that you need to take into account. Fundamental frequency means here only at n equal to 1 and DC voltage. So up until n equal to 1. Okay, so up until n equal to 1. So only considering the fundamental frequency for XST, we need to determine the complex exponential Fourier Series equation for voltage here across the resistor V1T up to the first harmonic. It means that you need to find the voltage which is after the diode here. Okay, and then we need to write the complex exponential Fourier Series for current IT up to the first harmonic. Okay, now so we already obtained if we look here, it mimics the signal at CT. So we already obtained at CT. Okay, but we just take at CT for the fundamental frequency only. Okay, so if you look here at CT, is this one. So for the fundamental frequency, only this. Okay, only this part. Okay, however, we have to take into account also the new omega, because the signal here is 20 millisecond period. Okay, it has 20 millisecond period. So the new omega is actually omega is equal to from here, omega is equal to 2 pi over 20. So this is equivalent to 100 pi. Right, and then we have at CT, if we look at CT only at the fundamental part, we have 4 over pi cosine 2 pi multiplied by 10 power of 40 minus pi over 2, right? And then the amplitude is also the same, because the peak-to-peak voltage for ST here is given as 2 volt. Peak-to-peak means from the negative amplitude to the positive amplitude is 2 volts. So the amplitude is actually 1 volt. Okay, if we talking about the sine wave, this is peak-to-peak value. Okay, so peak-to-peak here is 2 volt. So the x naught here is actually 1 volt only. right? So basically it's the same as XCT. Okay, so now to obtain XST, we just need to change the omega here. So XST is actually 4 pi cos 100 pi t. Okay, so 100 pi t is the new omega here, minus pi over 2. Okay, so to make our job easier, we can change cosine here to sine, because cos t minus pi over 2, if we use the trigonometry series, this is actually 4 over pi sine 100 pi t. Okay, so let us draw 4 over pi sine 100 pi t, so that it is easier for us to imagine. Okay, so this is XST, this is t, okay, and the duration here is 20 milliseconds. Okay, and to obtain V1t, this SST is has gone through this diode. So this, if it has gone through this diode, we have to consider only the half wave, okay, because it has been rectified. So the signal from this SST becomes half wave rectified. So it means that we cannot consider like the negative part of the signal. Okay, so this has become half wave rectified. So we have to find the new coefficient. Okay, coefficient, Fourier Series coefficient, based on the table, has been found out that for half wave rectified, C0 is equal to x0 over pi, C1 is equal to negative j x0 over 4, and C negative 1 is equal to j x0 over 4. So remember, the question asks you to consider only fundamental harmonics, so only C0 and also C1. And for this XST, the amplitude here is 4 over pi. So if we put in the formula, this is 4 over, x0 is 4 over pi, so it becomes 4 over pi squared, and C1 become 1 over pi exponent negative j pi over 2. Okay, if you want to remove this negative j, and C negative 1 becomes 1 over pi exponent j pi over 2. Okay, so how did I come up with this? X0 here replace with 4 over pi, so you will get this. And then from there we can get V1t, which is equal summation of all of these in terms of complex Fourier series coefficient, 4 pi squared plus 1 over pi exponent negative j pi over 2 exponent j 100 pi t, okay, which is the new omega. Okay, so don't forget to multiply this exponent j 100 pi t. Okay, it is needed. Okay, you can look at the equation from Fourier series table, and then 1 over plus 1 over pi exponent j pi over 2 exponent j 100 pi t. Okay, so this is your new V1t. Question is, you have to find the complex exponential Fourier series equation for current IT, okay, up to the first harmonic. So it means that you can just divide Vt by the total impedance. So you need to find the total impedance first. Here the Vt, so we need to find the total impedance. So Zt is given as R parallel with Xc. Okay, basically you calculate the values of total impedance, okay, and then divide by R plus 1 divided by j omega c. So R is given as 1 and C is also given as 1. Okay, so basically Zt you will get 1 divided by 1 plus j omega. Okay, so I already simplified this. Please find out how I simplified this. And then we need to find out Zt for each of the omega. So omega that we considered here is omega equal to 0. So Zt is equal to 1 divided by 1 plus j0, which is 1. And then for omega is equal to 100 pi, Zt is equal to 1 divided by 1 plus j 100 pi, okay, which is equivalent to 1 over 100 pi, and and this one is actually this one is negative 89.8 degrees. Somehow it almost negative 90 degrees, so I just put negative 90 degrees. Okay, I just rounded it to negative 90 degrees. So this is what I obtained. Please let me know if I obtain wrongly, if I calculate wrongly anywhere in my steps here. Okay, and then from there we can find IT for each of these omega. Okay, so you can just put here IT is equal to VT divided by ZT. Okay, so VT we have here 4 over pi squared for omega equal to 0. So divide by 1 is still 4 divided by 4 over pi squared. Okay, and then we have this one. Okay, you can divide by ZT when omega is equal to 100 pi. Okay, so 1 over pi exponent negative j pi over 2. Okay, so I just write this one back for you. T up here divide by ZT. Okay, so and for this part we have divide by 1, so it's we'll get the same answer as well. Okay, so solve for this. Okay, this is what I obtained, plus this one is 100, and then because this is negative pi over 2, so you can actually add together the phase. So negative pi over 2, when this negative 90 degrees you bring to the numerator, it will become positive 90. So negative 90 plus positive 90 will become 0. Okay, so this part has been cancelled, so only exponent j 100 pi t. And for this part, so also 100 here, and then this is pi over 2, and this negative, bring it to the numerator, it become positive, so pi over 2 plus pi over 2, it become pi. So this one is exponent j pi, exponent negative j 100 pi t. So because this is a current, so the units is ampere. Okay, so this is I have answered all the question for question Fourier series for 2019-2020 past question. So it is quite tough, I know. So I hope that this tutorial or this revision benefited you in some ways. Thank you very much for listening to my video.